Okay, today in chemistry we're going to continue on with our gas chapter, so we're going to start our gas laws. So the first law we're going to do is Boyle's law, and Boyle's law deals with pressure and volume. So we're not changing temp, we're not changing moles of a gas, so it only involves pressure and volume. So in the 18th century, Robert Boyle said that if he took a fixed amount of gas and held it at a constant temp and he squeezed it into a smaller space, the pressure would increase. So you know that. So if you take a balloon, it's blown up, tied off, it's got a certain volume. If you squeeze it down, it's going to create more pressure against your hand. Your formula is P1 V1, so P1 times V1 so is equal to P2 times V2. So this is your initial pressure and volume, and this is your final. Okay, so it says what volume will 2.50 liter of a gas occupy if the pressures change from 760 to 630? So I'm going to work on a separate sheet. I didn't leave you much room. So our initial volume was 2.50 liters. And when you read it, that pressure started at 760, so that's your pressure 1. So remember, millimeters of mercury, ATM, kPa, those are pressure units. And we're going to change our pressure to 630, so we're going to decrease it. And we want to know what that volume will be. So when you do your homework, you need to show a manipulated formula on every problem you do. So here's your formula, and we want to find volume 2. So you're going to divide both sides by pressure 2. Okay? So your formula will be V2 is equal to P1B1 over P2. Your pressure 1 is 760 millimeters of mercury. Make sure you show your work. Make sure all your numbers have units. Volume 1 will be 2.50 liters. We're going to divide it by our pressure 2, which was 630 millimeters. Okay? You have millimeters in the numerator and the denominator, so it cancels, so you're left with liters, which is a volume unit. So you take 760 times 2.5, divide that by 630. So your pressure will be, and you want 2 sig figs because of the 760, will be 3.0 liters. So we decreased our pressure, so you would expect that to go with an increase in volume, which is true. Okay, our next question. It says a given mass of hydrogen occupies 40 liters at 760 millimeters. So 40 liters is our initial volume. And that pressure that it's at is 760 millimeters. And we want to know our new volume. So once again, we're looking for volume again. And we have a new pressure of 5 atm. So here's our first problem. This is an ATM unit, this is a millimeters. You want your pressure units to be identical. So if you'll remember, 760 millimeters is the same as 1 atm, so that's the path of least resistance. Okay, so if we have P1V1 is equal to P2V2, once again we're solving for V2, so we're going to say V2 is equal to P1V1 over pressure 2. Our initial pressure was 1 atm. You could have gotten both of them to atm, you didn't have to. You could have gotten them both to millimeters. And then our initial volume was 40 liters. We're going to divide that by our new pressure, which is 5 atm. Atmosphere will cancel. So you're going to take 40 divided by 5 would be 8 liters. Okay? And you want 1 sig fig because of the 5. So we had a increase in pressure, so you would expect that to go with a decrease in volume, and it occurred. Okay, our last question. Gas sample occupies a volume of 200 mils, so that's your volume 1, 200 mils. And the pressure it's at is 400 millimeters. What pressure, so we want to know what our new pressure is going to be if we change our volume to 75 mils. Okay, so we want pressure 2, so we're going to divide both sides by V2. So pressure 2 is going to be P1V1 over V2. So pressure 1 is 400 millimeters. That volume was 200 milliliters. And then we're going to divide it by our volume 2, which was 75 milliliters. This time milliliters will cancel. You'll be left with millimeters of mercury, which is a pressure unit. So 400 times 200, we're going to divide that by 75. So our new pressure is 1,067 milliliters, and we want, okay, so the way it is, let's go ahead and put a decimal here and here, so we at least have 3 sig figs. So if you do this to 3 sig figs, here's your third sig fig, so you'll say 1070 millimeters of mercury. Let me check that again, that just seems strange. Nope, it looks fine. Okay, so whenever you work with Boyle's law, you should notice that if pressure decreases, your volume should increase, or vice versa. So we say that is inversely proportional. Okay, so that takes care of this section. So you'll do your Boyle's law homework set. Thank you.